Hi guys, today we are going to be talking about implicit differentiation. And before we can start doing these, we have to know what it is. Implicit differentiation is the process of taking the derivative of a function, equation, expression that has multiple variables with respect to x. Okay, now let me kind of do a little bit of work here. So here's what we have been doing. We've been taking the derivative of something like x squared. Okay. You all have just been writing 2x. However, let's put this in perspective of derivative notation. I'm taking the derivative of x with respect to x. So I would actually put dx to the side that says derivative of x with respect to x. However, anything divided by itself equals 1. So that's why we've just been writing 2x. Now, this changes the game when I do the derivative with respect to x of, say, y squared, which I realize is number 1, so we're going to change number 1 here in a minute. I'm just going to take the derivative as if it were normal. Derivative of y squared would be 2y. But then I have to make the comment that I took the derivative of y, but I did it with respect to x. Okay? So, I'm going to change this problem. Let's make it a cubed. Okay. So the derivative of y cubed means I'm going to take the derivative like normal. So I'd have 3y squared, but then I have to make the comment. I took the derivative of y with respect to x. So we would tack on the dy dx. Okay. 3y squared plus 2x cubed. I'm being asked to take the derivative with respect to x. So this would be 6y dy dx plus 6x squared. Technically, I would have dx, but what's going to happen to dx? It's going to cancel itself out. Okay. The derivative with respect to x of x squared times y squared. So I have a product rule. All my derivative rules still apply. Derivative of the first, keep the second, plus keep the first, but when I go to take the derivative of the second, it's a y, so I would have 2y dy dx. And if you all haven't figured me out by now, I can't stand numbers being weird. And I'm not going to count you wrong if you don't. I just personally cannot leave that 2 in the middle of that problem. Okay, so I need to make that comment. So all the derivative rules still apply, meaning chain rule, product rule, quotient rule. We're still going to be using all of those. Sorry. Okay, so in our important ideas, the derivative of anything with x in terms of x, we're just going to handle this like normal. The derivative of terms with y in terms of x, we must include dy dx at the end of anything that we take the derivative of that has a y attached to it. Okay. Now, these first 3 problems are not what you're going to be asked. I mean, it's part of what you're going to be asked to do today. Okay. What you're going to be doing is When we take the derivative of an equation, that involves multiple variables, we're going to have to solve for dy dx. And remember, derivative in any form, all this still stands for or finds the slope of the tangent line. So we are going to be writing a couple equations of tangent lines in this lesson again. All right, so we would have 2x plus 2y dy dx equals, the derivative of 1 is 0. I have an equation, I know that because I see an equal sign. I have to solve for dy dx. So I'm going to subtract the 2x over to the other side first. It doesn't look as pretty, guys, but all this is algebra manipulations. After you take the derivative, you're just manipulating equations. I need dy dx by itself. It's being multiplied by 2y, so I'm going to divide both sides by 2y. 2's cancel, I end up with negative x over y. So the derivative with respect to x is negative x over y. All right, number 2. Yes, I have an equation, but I also have a product going on. So product rule applies. Derivative of the first, keep the second, plus keep the first. But now the derivative of y would be 1, but then I have to include dy dx. Equals, derivative of 2 is 0. I want dy dx by itself, so I'm going to take this term that does not have the dy dx over to the other side. And then I'm going to divide both by x to the 5th. I can reduce again because I've got an x to the 4th over 5th, so those would cancel, leaving me with negative 5y over x. Number 3 is a bit of a doozy. So first, I would have 4y cubed, but I have to have dy dx, plus, I go to take the derivative of this term, I have a product. So derivative of the first, keep the second, plus, keep the first. Derivative of y is going to be 1 dy dx equals 3x squared minus 1. Now, I have more than one dy dx term, so I need to keep those on the same side of the equation. So I'm going to take this 1y over to the other side. I have a habit to write all my variables first. Could you put the minus y at the end? Sure. Now, here's where, once you see this done once, you'll be like, oh, that makes sense, not a big deal. I have dy dx in 2 terms. I have to factor it out. If I factor dy dx out, I'm left with 4y cubed plus x equals this. Now that I've factored out the dy dx, I can divide both sides by the 4y cubed plus x. Okay, so anytime you have multiple dy dx's in your problem, you will have to factor. Okay, but it's not in-depth factoring like what we're used to. It's just pulling out a GCF of dy dx. Okay. Derivative of x is 1 plus the derivative of sine is cosine, but it's a y, so I have to include dy dx, equals, oh, got a product, derivative of the first, keep the second, keep the first, derivative of the second. Now, I have multiple, I'm sorry, didn't mean to do that. I have multiple dy dx's, but they're on opposite sides of the equation. So I need to get all the dy dx's to one side, everything else to the other. So I'm going to bring, oops, I forgot to change my color. So I'm going to bring this over to the left. And I'm going to take this constant of 1 over to the other side. Okay, not trying to confuse anyone. I moved the dy dx term to the other side, and I moved the 1 to that side. Okay. Now my dy dx's are together, so I can factor out a dy dx, which then would leave me cosine of y minus x. And then I can divide both sides by cosine y minus x. Okay, number 5. When I go to take the derivative of the first, I don't have e to the x, I have e to the 2x, so I actually need a u. So I would get 2 e to the u, so I multiply that together for my derivative, so I would have 2 e to the u, which was 2x. That's that derivative, plus the derivative of natural log is 1 over y, but it's a y, so I got to do dy dx, equals 2. I want dy dx by itself, so I'm going to subtract this over to the other side. Now I want dy dx by itself, so I'm going to multiply both sides by y, because y times 1 over y will cancel that. And that will make 2y minus 2y e to the 2x. Okay, one last one, finding, and I'm asking you just to stop at the slope, okay? On your homework, you will be asked to write the equation, which I may go ahead and write the equation anyways, but slope of the tangent line means I have to take the derivative. So look here, I've got another u. So fu would be e to the u. That would be 1 minus the derivative of y is dy dx. E to the u is e to the u. So I've got 1 minus dy dx times e to the u, which was x minus y, equals, that would be 4x minus 2y dy dx. Before I can get my dy dx's on the same side of the equal sign, I'm going to have to get rid of these parentheses. Now, I'm going to get my dy dx's to the same side, so I'm going to add this guy over to the left, and I'm going to take this one over to the right. Sorry, I didn't give much room, so I'm going to go right here. So I would have 2y dy dx minus e to the x minus y, dy dx, is now equal to 4x minus e to the x minus y. I'm going to factor out my dy dx. I'm going to divide both sides by this. Oops, I didn't mean for that to happen. Oh, I did not give nearly enough room for this problem. I'm sorry. So now I've got dy dx is equal to 4x minus e to the x minus y over 2y minus e to the x minus y. But if I look back at my problem, I'm told a coordinate. Hey, guess what? Coordinates are x, y. I know what x and y are, so I'm going to take those values and I'm going to plug them into my equation. So then I get 4 minus e to the 0 over 2 minus e to the 0. What's anything to the 0 power? Please do not say 0. I get 4 minus 1 over 2 minus 1, which is 3. That is the slope of my tangent line, which I know this question didn't ask, but therefore the equation would be y minus, what was our y1 value, equals slope times x minus, what was x1? This would be the equation of